In this video, we will describe the pattern of argument called syllogism. In general, a syllogism is an argument with two premises. But what makes it a categorical syllogism is that all propositions, that is, all the premises and the conclusion, must belong to one of the basic categorical forms. Since a conclusion is a categorical proposition, it must contain both a subject term and a predicate term. Let us give the name S to the subject term of the conclusion, and P to the predicate term, also of the conclusion. So one of the requirements is that exactly one premise must contain S, that is, the conclusion subject term, as its own subject term. The premise whose subject term is the same as that of the conclusion is called the minor premise. Likewise, exactly one premise must contain P, that is the conclusion's predicate, as its own predicate term. And this one is called the major premise. Finally, exactly one premise must contain what is called the middle term, that is the term that links or connects S and P, as we'll see. We can use Venn diagrams to represent the information contained in the premises of a syllogism, and thus to determine whether the syllogism is valid. To the left, we have the general form of the syllogism. The gap that precedes the subject term indicates that the proposition can be either universal or particular. That is, it could be preceded by either all or some. The gaps to the left of the predicate term are to indicate whether the proposition is negative or affirmative. If it is negative, it contains not. If it is affirmative, it doesn't contain anything. Notice that here, in the case of syllogisms, we're going to be dealing with three terms. And this can be observed here in the Venn diagram to the right. Since we have more circles, we also have more areas. In particular, we have 8 areas. For instance, 1 is the area of those that are F, but are neither G or H. Area 4 contains those that are both F and G, but not H. 7 contains those that are F, G, and H. And so on until we get to 8, which is the area of those that are neither F, nor G, nor H. Take this categorical syllogism as an example. First premise, all crocodiles are reptiles. Second, all reptiles are heroic. Conclusion, all crocodiles are heroic. So we can see that all premises and conclusions are in categorical form. The first thing we'll do is find the minor premise. Remember that the minor premise is that one which has the same subject term as the conclusion. The subject term of the conclusion is crocodile, and premise 1 contains crocodiles as its subject term. So 1 is a minor premise. And which one is the major premise? The major premise is that whose predicate term coincides with that of the conclusion. The predicate of the conclusion is heroic. So premise number 2 is our major premise. And which of these is the middle term? The middle term is the one that appears in both premises, which in this case is reptiles. So let's represent our first premise in the Venn diagram. This is a proposition in the form all S are P. Remember that our procedure for representing all S are P was to shade the area of S that did not overlap with P. We did that to indicate that that area was empty. In this case, S is crocodiles and P is reptiles. We can see that C is divided into 4 areas: 1, 4, 5, and 7. Out of those, exactly 2, 1 and 5, do not overlap with R. So those are the ones we shade. And here we have the representation of all crocodiles are reptiles. And we follow the same procedure for premise 2. In this case, S is reptiles and P is heroic. So we're going to be concerned with circles R and H. Again, R contains 4 areas, and out of those, 2 do not overlap with H. That is, there will be the areas composed by reptiles that are not heroic. And what we have to say is that those areas are empty. So those areas are 4 and 2. So we shade them. And now we have a representation of both premises. All crocodiles are reptiles, and all reptiles are heroic. The conclusion is all crocodiles are heroic. Does this Venn diagram representation make the conclusion true or not? If it does, then the argument is valid, because then the information contained in the premises is sufficient to make the conclusion true as well. If it doesn't, then the argument is invalid, because that means that the conclusion has some information that is not contained in the premises. So it would be possible for the premises to be true and the conclusion to be false. Okay, in all crocodiles are heroic, S would be crocodiles, and then P would be heroic. So we're dealing with the C and H circles. And to make 3 true, then, we have to shade all of the areas of the crocodile circle that do not overlap with the heroic circle. Now, notice that the only area of C that remains unshaded is 7. So that's where all the crocodiles are. But this means that the only area that has crocodiles, which is 7, falls completely inside the heroic circle, which is an indication that all crocodiles are heroic, according to this diagram. Likewise, we can see that all of the areas in the circle of C that do not overlap with H, that is 1 and 4, are shaded. This means that by making both premises true, we also make the conclusion true. Thus, the argument is valid.